All right, hello everybody. We'll get started. What a great couple presentations we've already seen today. So first of all, I'd like to start off with a question. How many of you have shopped on Black Friday or Cyber Monday? Okay, just about everyone here. So as you know, this is a very busy time for companies, especially businesses that host websites as well as their physical appliances on the server side, and it puts a really big strain on the cyber infrastructure of a company. So surprisingly, last year Walmart had a 100% uptime for their server infrastructure. So how did they manage to do this, you might ask? Well, that leads us into our discussion today.
So our project for this semester was deploying and managing IT infrastructure for a fictional company called ACME using cloud computing. I'm Hunter Keller, and I was a collaboration engineer and team lead.
Tim Jansen, Secured Systems Engineer.
Bryce Blankenship, DevOps Engineer.
Tanner Vass, Remote Site Engineer.
So that was the team. Our sponsor for this semester was Cisco, and more specifically, the High Touch Delivery team. And I'd like to thank Brandon for being here and sponsoring us for that. So today, we're going to talk about that problem statement, about ACME, and what they wanted to do with cloud computing. We're going to talk about cloud computing and its concepts. We're going to talk about what we actually got to do in our lab. We'll show you how it works and what you can do within what we did in the cloud computing. And then we'll wrap it up with what we learned over the course of the semester. And also, I'll open up to questions from you.
So we were presented with Acme Corp, a fictional retail company that has had a long-time successful business in the brick and mortar sphere, but is recently expanding into e-commerce, and their network is having problems growing and scaling with this. So we were tasked with redesigning a secure network for them that has bring your own device and wireless capability, as well as being easy to scale, because Acme is opening 3 new stores this year, and they plan to keep opening more in the future.
So for the first 3 weeks, we designed the high-level design for what we wanted the network to look like, and then we presented that to Cisco. And after that, we have just been working on our proof of concept for Acme's network and writing the low-level design documentation. So what is cloud computing? At its simplest form, cloud computing is just accessing your resources via the web. And there's 2 types of cloud computing. There's public cloud computing and private cloud computing. So public cloud computing is where you rent server space from other companies like Amazon Web Services. This is mostly for smaller companies who don't need high compute resources. Then you got the private cloud, which is where you own your own hardware. You're able to do whatever you need to, you secure it down, you run your own software. There's some paid versions like VMware's vCloud, and then there's also free versions like OpenStack. And then there's 3 levels to cloud computing. So there's infrastructure as a service, and that's where your network admins work. Then you got platform as a service, and that's where all your developers develop their applications the end users will end up using. And then you got the software as a service, and that's where all your end users will access all the resources the developers have created.
So why go with cloud computing? Really the big thing for Acme was the centralized management. All of our services that we're using are able to be accessed through a few different web pages where you can centrally manage everything for all the branches across the country. Cloud computing also allows for having an agile, scalable environment that can change and adapt to things such as Black Friday shopping, where you have a huge influx of users on both your website and your POS systems at the stores. And also, cloud computing can provide cost savings in the long run, depending on what you end up going with for it, which we'll talk about more now.
Okay, so bringing it back to Walmart and their 100% uptime. So they use cloud computing, and in their core of their network and their server infrastructure, they're using OpenStack. So OpenStack is also used by many other companies in the industry, many here that you recognize, including NASA. So NASA and Rackspace actually got together back in 2010 to create OpenStack. So now I'll go into why a company may want to use OpenStack in the first place. First and foremost, it is open source, meaning that it's completely free. The startup cost is absolutely nothing, so that makes it really great for Acme since they are getting into the cloud computing aspect, as well as you won't have to deal with any audits from any other companies if they use licensing. Next off is the resource distribution. So Acme has different development teams in its infrastructure, such as an app dev team, a web dev team, as well as it has its own systems engineers that run their infrastructure. So with this, we can create pools of hardware resources that can be assigned to these different teams. The next aspect is the self-service portal. So OpenStack has a managed dashboard that you can go on and manage all your different infrastructure, such as your networking, your instances, as well as your storage. So that's really great because it's all in one spot that the app dev team can go on there and launch their VMs really quickly. You no longer have to go through a SE team or security or the storage team. It's all in one place really quick. You can get started with that, or you can even use a Python script to kick this off. And then lastly, it scales very, very easily. So they can start off with just a few servers and grow as the company matures and expands over time. They can install the OpenStack services on their servers and get up and running in no time. So for our private cloud, we're going to be hosting at the ACME headquarters location. With that, I'll be hosting their e-commerce website, which will be agile and scale as more people come online, as well as the physical store locations and teleworkers will have VPN access back to the ACME private cloud for their corporate applications. We'll also be using the Cisco Meraki public cloud to manage our BYOD solution called Systems Manager, as well as all of our networking equipment will also be centralized managed in one easy-to-use dashboard. Okay, so to give a brief overview of how OpenStack actually works and the architecture behind it, there's the one dashboard. Now the surface is actually called Horizon, and that kind of pulls everything together in one central spot. With that, it uses the Keystone Identity Service. So this pulls everything together because it's all based on Python. So this Keystone service logs into the backend API of all the services, and with Horizon, pulls them all together. So the Nova Compute aspect, that takes care of all your hypervisors. There's open source ones available that we are using, and there's also, you can manage VMware's ESXi, as well as Microsoft Hyper-V if you wanted to. There's also Cinder, that takes care of the block storage, all your storage aspects can be taken care of with that, which can be used in conjunction with the Nova Compute service. And then there's Neutron. So this is all your software-defined networking. It can run high-level networking features such as vRouters and open switching, or open vSwitch. And then there is also the Glance imaging service. So this is a really important aspect of OpenStack because with this you can upload cloud images to the Glance imaging service, and that gets pulled into the compute service, which we'll talk about here a little bit in our live demo. And then lastly is the object-based storage service. So this is really great if you have large amounts of data. So as ACME grows, it can get into using this later as it moves into a bigger commerce website.
So this is what our actual lab looked like. This is what we could pull together from Pierce, who was the lab manager, which he gave us these servers, and then we also had Tanner, who actually had these Cisco Meraki appliances. But we did want to use Cisco Meraki here because that's our public cloud infrastructure that we wanted to contrast with that public cloud of OpenStack. We wanted to use a little bit of both to find out what they're good at. And then also we wanted to have at least one proper Cisco product in here. But unfortunately, CUCM does not play nicely with OpenStack, or at least the environment that we're using. And it was kind of a all or nothing thing there. So we didn't get to do a whole lot with that, unfortunately. And as you've also heard about all of the awful power outages, the big one was the one after spring break. So we come back from vacation, boom, firewall's gone. Luckily, Tanner had a Z1 teleworker gateway, so we got to use all the same features, but it's not really the same thing. So this is what our lab network looks like on a logical perspective. We have the controller node, and that's where most of those services that Bryce was talking about sit. We have the compute node, so that just runs that compute service, but that's where all the heavy lifting and power for running those instances is. And then we have the networking node spun off on its own, so that handles all of our networking Neutron service. So this red line here, down on the bottom of the compute node, you have the VM, that's your instances. You can apply a security group to those, and those are basically ACLs that determine what kind of traffic can connect to that instance. Then those are also organized into a project network, and then from there it goes into the virtual switching over to that networking node, into the virtual router, which also has a firewall feature enabled upon it. So you have a virtual firewall alongside that physical firewall. And then outside of the networking node, it goes out into the physical switch network, and it's just like any other data traffic.
So we talked about why we wanted to use OpenStack. Why did we use Meraki for this project? Well, as Hunter said, part of it was I did have the equipment myself, and we were working with zero budget for this, so what we had is what worked. But also, Meraki has a unified dashboard that allows for easy access and management of all the configurations of all the devices across the organization. So this will allow for ACME's IT team to be able to manage all the networking stuff from within the HQ location. And it also allowed them to spin up stores really quickly. It's basically just plug and play after you have the templates configured for it. We also chose to go with Systems Manager, which is another Cisco Meraki product for the mobile device management solution for ACME. So Systems Manager uses the same exact dashboard, and it allows you to basically set up a BYOD policy for your company that will take any kind of device, and it's easy. That QR code up there is actually the one from our network. The users could bring in their own devices and just download an app, scan the QR code, and then their device is enrolled in the network. And that's actually something we're going to demo for you here today. So Tim's going to pull up the dashboard online, and we'll go into add a new device. And right up there, we'll be able to see the QR code after he scrolls down. Bryce here is going to drive my phone and scan that in. So this QR code is something that could be like printed off and distributed to people. You can send it out in an email, do whatever you want, and make it really easy for people to register their own devices to be compliant with the network. So the next thing, we don't have time to show off all the features of this solution, but we're just going to show a couple things. These are just some basic apps that we put on there that will be provisioned to all the devices as soon as they're on the network. You can scope these out into different types of users and also use paid apps through like Apple's volume purchasing program and such. Is the device almost enrolled now? All right, so we should be able to head over to the clients page now and take a look at the device on there. Should be checking in at this point, and there we see Tanner's iPhone has been added. So we're gonna open up the details of that device. So up at the top here, you can just see all the device details right away, the serial number, the model and everything, and this can be used for ACME's asset tracking and just knowing what they have in their network. It'll also automatically show the GPS location of the device as well as other details such as the storage and network settings. If we keep scrolling down here, we'll be able to see the mobile device management command. These, along with the security policies, are really what is going to come into play with ACME as far as securing their network. This will allow them to lock down devices, wipe devices that are lost or anything like that, as well as send notifications, which Tim is going to do here, has done that almost every time. And so yeah, you can even fire people on the spot with your mobile device management solution. So with that, that's just how to enroll a device in there, how quick that is. Now we're going to move on into OpenStack and show you a little features in that.
Okay, so right here we're looking at the Horizon dashboard. This is the central management plane for your OpenStack private cloud. So first and foremost, up here is a drop-down menu. So these are called projects. These are where you set your quotas and your hard limits for resources to these different teams. Here we're looking at the application element team, and this is the summary page where we can see we can have 10 VM instances running, as well as we can have 20 vCPUs and 50 gigabytes of RAM. You can also set storage limits on this as well. So we want to show how easy it is to kick off VM instances with this dashboard. So here we click Launch Instances. First thing you can do is you sign your name. Get that typed in here, and then down the bottom you can set how many VM instances you want to create. In this case we'll just do a couple, but you can do tens, hundreds, or even thousands of VMs as NASA does. And then over here on the right you can see the quota and how much you're actually using when these VMs are actually kicked off. Next we go into our source. So this is where the glance imaging service comes into place. Here we already have some pre-populated VM images already up in here. So the first thing you do is you select which one you want. In this case we have a lightweight Linux kernel which we're going to pull into this VM. Next you go into flavors. So flavors are the hardware resources you assign to these virtual machines. There's some that are already pre-populated or you can custom create your own. In this case all we need is Tiny because it is a lightweight Linux kernel. And then we move into the networking aspect. This is where you select the subnet that you want your VM to reside. That takes place within the Neutron service, so we'll go ahead and select that. We have our app dev subnet. And then last thing you need to do is specify a security group. So security groups are basically ACLs, or access control lists, that are applied to the network interface of the VM. So that just helps with a little bit more fine-tune and fine-grained security. So we'll go ahead and select that. This will only take a few brief moments as this kicks off. It'll show the different phases that it goes through. First you'll see it goes to a scheduler. So that kicks off and it talks to all the other services that are running and configures it all together. So the first thing it does is you'll see it goes to the networking phase here in a second. So once that goes, it'll see the IP address. It'll pop up in that pane there. So it makes it really easy to see with transparency where your IP addresses are located and which ones are where. And then after that, it goes into spawning stage. So that goes into the cinder block storage as well as the the Nova Compute service. So that only takes a few brief moments, and then once that's done, we can go into the console page and just see how easy it was to set this up. So you'll see that there's actually no install process at all, because the images are already pre-compiled, everything's already set. So you can have a Windows server even up and running within a few brief seconds. So once it's up, we'll have Hunter log in just to show that everything's up and running, that he can log in and ping out to the internet, and just show that all the services and everything are working together actively. So here it is, up and running. We'll go ahead and log in. And okay, perfect, works great. So just, you can see how easy that is for ACME. As a company needs application development teams to go on there and spin up VMs to pull down their source code from GitHub or any other source control, you can do this very quickly and easily. And then lastly, in our live demo here, we want to show off our ACME website, which is hosted in our private cloud. This is, of course, speaking out to our Pig Latin crowd. And it's been up and running very smoothly, as well as if there's high load times, it can be provisioned with more hardware resources as time goes on. And that's the end of our live demo. We'll head back to our slides.
So, if you're an organization like ACME, or probably more likely here, you might have a customer that's like ACME or an organization, and these are the real things you're going to care about from ACME. You're going to care about that centralized management. You're going to be able to easily use those dashboards, and you won't have to have a huge IT department to manage all of your infrastructure and all of your services. You're also going to have that agile private cloud, so if you need to change whatever those needs are, you can easily do that on the fly. The big one is going to be you're going to have cost savings because you don't have to make a huge initial investment in those servers. Whatever you have laying around, OpenStack will take whatever computing power you have, as long as it can run on Linux. And then finally, the asset tracking, that's a big part from that public cloud from Cisco Meraki. This is very easy. You can access it from anywhere, and you'll be able to have your teleworkers and all of your employees securely managed or be managed from your network and be able to securely access your resources on your network. So this is like an overview of how the project went for us as a class. We've been pretty professional here, but also this is a class. The beginning of the class, we set out to make a high-level design and submitted that to Brandon's team. And that was more of a guideline after we learned over the course of the semester really what OpenStack could do. We didn't really have a whole great idea of what it could do in the beginning, and basically it changed a lot as we learned more about it. So that big part is, one thing we learned really quickly, OpenStack doesn't uninstall really nicely. You basically just have to wipe all of your servers, and we got really good at installing CentOS. I could probably do it blind now. Personally, on the technological front, I didn't know anything really about Linux coming into the semester. I knew really basic stuff, and as a cross-functional team, Tim and Bryce were the guys. They told me all kinds of stuff. I learned so much from them. And also, as more soft skill kind of thing, I haven't really been an organizing member in a lot of my groups, so that was something I really strived to be over the course of this project.
Technically, I just kind of learned about the private cloud. I didn't even know such a thing existed until this project. And then kind of as a team, I learned how to work with a team and teach each other how to learn a new software like OpenStack, because none of us really knew anything about it coming in.
Yeah, so I had an interest in cloud computing before we got started, so it was really nice to get a hands-on approach here and see how OpenStack works and what it can really bring to a company. On a personal aspect, working with this team here with everyone's different backgrounds and experiences, and having it all come together to create this project is really exceptional.
On a technical level, like Hunter, I really didn't know very much about Linux, so these two were invaluable in teaching me a lot of stuff about just the Linux operating system in general. And then on top of that, I've never really worked in a project that's taken this long, and this has been over the course of the whole semester, and it's finally getting here to what we're wrapping up with today. And to have a project that goes through so many revisions and updates and everything, it was really valuable because that's kind of how things work in the real world. A lot of the stuff in my other classes is just you work on it for a week and you present it and you're done. So it was a great experience.
So finally, we'd like to thank Cisco for sponsoring our project this semester, and the university for our program, and especially Holly for being a great program director. And now I'd like to open it up for questions from you. If there's something you'd like to see back in those OpenStack dashboards, you want to know more about how it works, now is the time.
Of all the services in OpenStack, which one do you guys think was the hardest to set up?
Definitely in the beginning, Cinder. So we had a set of scripts called PackStack to install OpenStack onto our different nodes. And it was really nice, it was automated. You just set up this answer file, but in the answer file, it was originally set to have Cinder only have 20 gigs of space. And that ended up being a problem because we wanted to use more than 20 gigs, considering we had about 4 terabytes on our server. So navigating around within Cinder, and also I delved into the CLI trying to fix this too, and I learned a lot about that.
Did you guys have a chance to look at heap orchestration for floating IP addresses on Neutron?
Yeah, so we didn't actually get to heap, but we did use floating IPs for the external, for like the website. We did use those, so we could set up the pools to be, when we spin up more web servers or something like that, we would pull from that.
Did you look at any of the potential issues that might limit the scalability of using something like this for e-commerce, having to meet standards for like things like PCI compliance, where you have to have some segregation of e-commerce systems from other systems?
Like, we really didn't have a whole lot of equipment to work with, but our idea was all of the features that we did touch within OpenStack, we wanted to make an effort to try and secure them. So like we made we had our ACME project, so we wanted to make an ACME security group that we could apply to those instances. So you saw that. We did some hardening on our actual hosts that were running OpenStack. We used the isolated networks for each of the projects. So we couldn't really get all the way deep down in the PCI. It wasn't really a PCI project too. It was more about exploring OpenStack, but we did want to take advantage of the security features we had the resources to do.
So I'm sure in Microsoft's 100% uptime environment that they have multi-site redundancy and this is spread across various data centers in various parts of the country. And it all has to tie together and it's all is applied. So how did you guys do any research into how this product scales over distance? I mean, is it very latency intensive where, I mean, you have to dedicate links between the sites, and you run it over again?
Well, one consideration that comes to mind right away for that is between the compute node and that networking node. So all the networking for those instances comes out that networking, but those two nodes have to be connected by an Ethernet bridge, or at least in our environment, that's how it works. You probably do something with fiber connections and it would be a lot more better performing, but those for us, we had just a normal copper connection between them, and I could see where distance would come into a factor there.
Yeah, going on that a little bit more, in OpenStack you can set up availability zones. So those are like different clusters of high availability servers you have. So you can set where you want to deploy those. So you can set up different geological locations with that. We just didn't have the hardware to set up another HA available pool, but you definitely can.
That's it. Thank you for being here, and
Hunter, I got a question.
okay, thank you.
Looking at the amount of hours you guys put in your timeline there, how would you guys, knowing what you know now, and your other projects have done, how would you guys manage your time a little differently? It looks like at some point, halfway, 3/4 of the project, it's like, man, if you're upset in, number of hours you guys had to put in at the very end.
It does seem like that. It's not. It was less of panic after. It was more of panic before, but we didn't really know what to do because this was such a new technology to us. So we'd spend every week, we'd like come in and like trying to figure it out, and we'd be at home researching stuff, but that didn't really translate into specific lab time. Like, we had, like, I know Bryce spent a lot of time in the beginning with our high-level design, like, just trying to figure out, what is this? We don't know. We didn't know what OpenStack was to begin with, so, basically, right before spring break, we finally had, like, our stable environment, and then we could finally work on what we wanted to. Like, before that, it was a lot of, I'm gonna let this run overnight, and hopefully it works, and then it didn't, and then it started over. And we made progress really slowly, and then finally we got it to work, and then we started implementing things.
Great. Good job.
Well, thank you all.